Hello friends, it's Sujit Wagh. You are watching WikiNote channel. Welcome to the Advanced Processor Question Answer video tutorial series. Today in this video we are going to discuss about the question: draw an interfacing diagram for LED connected to port 1 of LPC2148 and write an embedded C program to alternately flash LED. See here, this question was asked in March 2018 exam for 5 marks, and here you have to draw the interfacing diagram. As just LED is mentioned, that means it is you have to connect just a single LED with LPC2148. So I will elaborate the answer of this question. So let's start. So my dear friends, here in the solution part you have to draw the interfacing diagram of LED with LPC2148. So LPC2148, I will draw the diagram over here. LPC2148 has 5 pins which are connected to the VCC. So show those 5 pins which are connected to the VCC, or you can call this as a VDD. 5 pins which are connected to the ground. And then we have 2 connections which are connected to the crystal oscillator input, that is oscillator clock, along with the capacitors. So the diagram looks like this. Okay, and in between these rectangle I will provide the name as LPC2148. As they have asked us to interface this to the port 1, so I will interface to the pin of port 1. But here one twist: to which pin you have to connect the LED? Because as I have to connect LED, I have to use the port pin of port 1 of LPC2148 as GPIO pin, and in case of LPC2148, port 1's port 1's P1.16 to P1.31 pin can be used as GPIO pin. So that means only 16 pins are available as GPIO pins. P1.0 to P1.15 are not available as GPIO pin, that is general purpose input output pins. So here my dear friends, that is the twist, that you cannot use simply P1.0 to P1.15 pins. I will use here any pin between P1.16 to P1.31. So I will use P1.16 here. So that will be my interfacing pin now. I have interfaced this LED to the P1.16 of LPC2148. So I have to write down the embedded C program for this. So this will provide me 2 marks, that is interfacing diagram, and 3 marks are for the program. I have already written that code here, and just simply I am going to explain the code now. So first statement is hash include LPC21xx.h. Its meaning is you have to include the header file. Then void delay void, this is function prototype, that is you can call it as a function definition. Then int main, that is your main function now. In that the first instruction is pin select 2 is equal to 0x 8 times 0. So 8 times 0. So what is use of this pin select register? This pin select register is useful for configuring the function of that pin as GPIO pin, because normal pin can perform 4 different functions. First, by default it can be used as GPIO, then first alternate function, second alternate function, and reserved or third alternate function. So here I am using the pin select 2 register. Why pin select 2? So for that you can refer my website www.wikinote.org. On that you will get the notes related with this topic. So I am just simply explaining about this P1.16, and you have to load 0 value for that. Next is IO direction 1. So as my dear friends, we have to set the direction of this pin, as we have to glow this LED, turn on this LED. So we have to send the data outside of the microcontroller. So you have to set the direction of this pin as an output pin. So that can be done using IO input output direction register. As we are using port 1, so that means you have to use here register related with port 1. So I will elaborate this. See here, IO direction, I will write down that register IO direction 1, and as I have written 0x 8 times 0, so 0x means this is a hexadecimal value, and I will write it in terms of binary now. First 0, 4 times 0, then I just make the group of 4 bits here like this. So I had to write down the zeros, group of 4 zeros 8 times. One, two, three, 4, 5, 6, 7, and this is last, that is 8. Now see here, my dear friends, I will match this value with the above value, same value. IO direction 1 is equal to, I have written 0x, and this 0, 0, 0, 000, the value is 000, then 1, then 0, then 0, 0 and 0. See my dear friends, this 0 is represented by 4 binary zeros, this 0 also 4 binary zeros, 0 by 4 times 0, and this 1, hexadecimal 1, will be represented by 0001. So this value will be 1. Again this 4 times 0, 4 times 0, 4 times 0, 4 times 0. So as we know that port 1 has 32 pins, that is from P1.0 to P1.31, but simply I cannot use this 16 pins as discussed earlier. This is, see here, I will write this bit is related with P1.0 pin, and this pin will be related with P1.15. You can count this P1.0, P1.1, P1.2, P1.3. Likewise, this will be P1.7, this will be P1.11, and this will be P1.15. So as I am using P1.16, so just you have to make that pin as high. So I have made that pin as high, and its value is 1. So that's why I have written the value as 0x 0001 4 times 0. Now you have set the direction of that pin. See here, configure P1.16 as an output pin. After that, I have declared while loop. So while loop means this loop will be executed infinitely. Then I have to send high value to this pin, and that can be done using register IO set 1 register. Why I am writing this one? Because it belongs to port 1. So the value, same value I have to send, because I want to send high value to the P1.16, and it's simple. Again, just 0x 000, then 1 and 4 times 0. So that value I have to send. That means LED will be on. Here I have written turn LED on by setting P1.16 as high. Then call some delay. So that means it will remain turned on for particular time interval. After that, IO clear 1, 0x 0001. So now here the concept is, in case of IO set and clear 1, you have to load the same value. And what is use of that, or why we have to do this? Because in case of LPC2148 register, this one define, I am writing this value into the IO clear 1 register. So this register will clear the pin which is set using IO set 1 register, and we have set through IO set 1 register we have set P1.16 as high, and again I am making that P1.16 as low. Again call some delay, and then provide in the delay routine you can see I have declared one variable whose data type is unsigned integer, and for loop j equals to 0, j less than, the value is about 10 lakh, j plus plus. Why I have taken this value? Because while in order to flash the LED, that turn on and turn off should be recognized by a human eye. So friends, we have seen a single LED interfacing with LPC2148. But what if the examiner asks you to interface 8 number of LEDs with LPC2148? Then what will be the changes in the program? So we'll see that. So first I have to draw the interfacing diagram of 8 LEDs. As discussed above, you have to draw the interfacing diagram. You have to connect 5 pins to the VCC and the 5 pins to the ground. Then you have 2 connections which are connected to the crystal oscillator, which will provide the oscillator frequency to the LPC2148, and in the square I can write LPC2148. Okay, as I have to interface 8 LEDs, I am taking the same port now. So you have to draw the 8 number of LEDs over here. I haven't drawn it properly, but yes, you have to draw it properly. And LED is shown by the symbol light emitting diode. So you have to show by using 2 arrows which are emitting the light. Symbol is like this, LED. Otherwise this will be treated as a diode. So keep in mind, always show this with the help of a light emitting symbols. So 8 LEDs I am using here, suppose P1.16 to P1.23. Go on counting this: 16, then this will be 17, 18th number pin, then 19 number pin, 20 number, 21st, 22nd, and this will be P1.23. So likewise I have used 8 pins of LPC2148. So as discussed earlier, you have to set the function of all the pins as general purpose input output pins, and for that you have to write the value into the pin select register. So the register which I am going to use here is pin select 2 register for the higher 16 pins of port 1, and you have to load the value 0x 4 times 0, again 4 times 0. For P1.16 to P1.23 you have to use the lower 4 bits of pin select 2 register, so that you can configure it as the general purpose input output pins. You have to write 0 to this pin because this 0 belongs to P1.16 pin and P1.17 pin. Next 0 belongs to pin 18, 19. Next 0, 20, 21. Next 0, 22 and 23. Likewise. Okay. So what value I have to load in IO direction register? So IO direction 1 register I have to load 32-bit pattern. So 4 times 0, as you know that every single bit of IO direction register is belonging to the 32-bit register. 4 times 0, again 4 times 0, 4 times 0, 4 times 0. Likewise you have to write it in 8 number of times: 1, 2, 3, 4, 5, 6, 7, and this will be 8. So this bit belongs to P1.0 and this bit belongs to P1.31. So now what value I have to load? I have to make 16 to 23 pins as high. So I will count here: P1.0, this will be P1.3, then this will be P1.7, this will be P1.11, this will be P1.15. But I cannot use these pins as GPIO pins, so I have to go from P1.16 onwards. So P1.16, 17, 18, 19, 20, 21, 22, 23, all pins I have to set their direction as high. So I will just make changes here. So this will be 4 times 0, 4 times 0, and 1, 1, 1, 1, then 1, 1, 1, 1, and 4 times 0 again, as it is 4 times 0, as it is 4 times 0, and as it is 4 times 0. Now see my dear friends, as this is a 32-bit binary value, I will convert this into hexadecimal. For writing it in hexadecimal, you have to write 0x, and it defines me that this is a hexadecimal value. 4 times 0 is represented by single 0, again 4 times 0, single 0. This 4 times 1, that means it is a F. This 4 times F, that means it is F. This 4 times 0 is 0. This 4 times 0 is 0. This 4 times 0 is 0. And next 4 are 0. So this value should be loaded in IO direction 1 register. And you have to say that means these pins are configured as an output pins. Through pin select register, I have configured their function as GPIO pins. Through IO direction, I have set their direction as an output pins. And if I'm done with this, then you have to set those pins at high. So IO set 1 is equal to same value 0x00FF and then again 4 times 0. And in the call some delay, and then after that IO clear 1 is equal to 0x00FF 4 times 0. And why I have taken this value, I have given that explanation in the previous part. Thanks for watching this video. Stay tuned for more such videos. Please like and share this video with your friends. Also refer my website wikinote.org. Follow us on our Facebook page WikiNote Foundation. The links for the same are provided in the description box below.